probably my favorite in stats. It's all the probability stuff. So again, we're going to combine two chapters for our unit, so we're going to look at chapters 5 and 6. I strongly recommend getting out your formula sheet today, so you have that to look at. We are on chapter 5, so it's all the probability things, and it does carry over to the back of that page. So all of the formulas, you don't have to memorize it. It's all given there for you. So when we're talking about probability, it's just the likelihood of something occurring. We know, how would we find the probability of something in general? Like if I roll a dice, what's the probability of rolling a 2? 1/6, because there's one side that's a 2 out of the 6 total sides. Now, does that mean that if I roll the dice 6 times, I will get 1, 2? I'm guaranteed. No. So probability, there's kind of different kinds. There's the probability like what we would expect to happen, but we know that in real life, that isn't always the way it works. I could roll my dice 6 times and never get a 2. But if I rolled it 600 times, do you think I would be more likely to getting a 2 about 1 in 6 times? Yeah, so the more trials you have, then the more our probability looks like what we expect. That is the law of large numbers. So we know if we only do it a couple times, it may not work out. If we're flipping a coin, we know there's a 50% chance of getting a heads. That does not mean if you flip it 5 times or 10 times, you will get 5 heads. But if you flipped it 1,000 times, you're probably more likely to get 500 heads. So the more trials we have, then the closer our probability we get to what we expect. Some notation when I talk, or definitions when I talk about a sample space, that's a collection of all possible outcomes. So it's everything that could happen. So if I'm going to roll my dice, what would my sample space be? What are my possible outcomes? 1, 2, 3, 4, 5, 6. If I'm flipping a coin, my sample space would be heads and tails. An event is a collection of outcomes. So maybe I roll my die 3 times and I get a 1, 2, 3. That's an event. The sample space would be every combination that I could get. The event is what we actually saw occur. So let's look at an example. So we want to look at the probability experiment of having 2 children. So part A, identify the outcomes of the probability experiment, I'm meaning in reference to gender. Okay, so if we have a child, the possible gender outcomes are boy or girl. So my sample space, that's a collection of everything that could happen. So if I have 2 children, I could have a boy and a boy. We could have a boy and then a girl. Would it be different to have a girl and then a boy? If your oldest child is a boy and your youngest is a girl, is that different than having the oldest a girl? Yeah. So we could have girl, boy. Or we could have 2 girls. So that's the sample space. Every possible outcome. Okay, so which ones would be the event having 1 boy? Which are the 2 that are having 1 boy? So that's just kind of getting you used to what we mean by an event, a sample space, the outcomes. That's everything that could happen. Any questions about that one? So a few rules with probability. If we're finding the probability, we will always get something between 0 and 1. We can have a negative probability. The maximum is 1, like a 100%. And if you add up all the probabilities for different outcomes, it would equal 1. Think of it as 100%. So if you add up the probability of everything, it'll always equal 1. We can make what's called a probability model, which just lists each outcome and its probability. And so we're going to do that in the next example. If something is impossible, what do you think the probability would be? Okay, if it is a certainty, guaranteed to happen, what's our probability? Yeah, An unusual is something that has a low probability, so it can happen. It's just not very likely. So typically, anything less than 5% is considered unusual. So you need a calculator. By the way, so suppose a bag of 100 M&Ms contains 12 brown, 15 yellow, 12 red, 23 orange, 23 blue, and 15 green. Create a probability model. So a probability model, it means you list the outcome and the probability. So my outcome would be my colors. So then we will list our colors. It doesn't matter what order you put them in.
I've already calculated.
Yes. Okay, so to find our probability, what are we going to have to know? The total. So we have 100 M&Ms. I gave you that. So to find each probability, what would I do? Yeah, 12 over 100 is, hey, yellow, 15 over 100 is, red would be, orange, blue, and green. And you can do a quick check. Did every one of these give me a number between 0 and 1? And if you add them all up, what do you get? So that is always something to check, just to make sure you don't miss anything. Make sure that when you add them up, it equals 1. Now, is it possible that it won't be exactly 1? Yes, if we have, like, maybe I'd only had 99 M&Ms, and so when I divided, I had really long decimals that I had to round. So you do have the possibility of rounding error there, but it should be very, very close. Okay, so now we're going to talk about empirical versus classical with our probabilities. So empirical is like what we see happen. You find the probability by the number of times that you observe it, divided by the number of repetitions in the experiments. So this is what we see. All right, if I take a dice and I roll it 6 times, and I want the probability of a 2. Okay, so I've got 4, 6, 6, 1, 4, 3. How many times have I rolled it? 5 and 3. So based on that, what's the probability of a 2? 0. Is that different than the 1, 6? Yes. This is empirical, is from what we saw. If I wanted the probability of a 6 based on what I saw, I rolled 2 6s out of my 6 total trials, so it would be a 1/3. So empirical is what we see. So an insurance agent insures 182 teenage drivers. Last year, 24 of the teenagers had to file a claim on their auto policy. Based on this, what's the probability they will file a claim? So what would I do? And we get, typically if it's not a nice decimal, I go to 4 decimal places. So 0.1319. So there's a little over a 13% chance they would file a claim based on this. So a class of 52 students is playing Pass the Pigs. Have you guys ever played that game? We have to play sometime. I really like it. You roll pigs instead of dice, and you get scores based on how they land. A lot of fun. I love that game. We played a lot in my house. All right, so use the results to build a probability model for the way the pig lands. All right, so I list the outcome. Frequency is how many times we saw it. If I'm going to find my probabilities, what would I have to do? Right. So let's add all these up. Is it 3,939? So to make my probability model, I just take each frequency divided by my total. Make sure you round accordingly. So this would be a prime example of when it might be beneficial to check yourself. How could you do a quick check just to make sure? Yeah, make sure they add up to 1. Potential that this will be slightly off because we did round, but it should be very, very close. So that's my probability model. Does it add up to 1? Anybody checking? It does. So we did good. We didn't mess it up. Alright, so part B, estimate the probability that a thrown pig lands on side with a dot. So, side with a dot is this outcome. And so our probability of that is 0.3285. Alright, would it be unusual to throw a leaning jowler? So, what does it mean to be unusual?
Less than 5%.
So if we look, a leaning jowler, as a percent, that is 0.81%. So that is unusual. Do we have any other unusual outcomes on this one? The snouter is also going to be unusual. Any questions there? So this is empirical. It's based off what we saw happen, based off that evidence. Classical is based on what we would expect. So like saying the probability of rolling a 2 is 1 out of 6. We know there's 6 options, only one of them is a 2. So if I looked at this one, a fun-sized bag of M&Ms contains 9 brown, 6 yellow, 7 red, 4 orange, 2 blue, and 2 green. Suppose a candy is randomly selected. What is the probability that that would be yellow? So what do we have to do first? I don't know. Okay. So how many candies do we have total? How many of them are yellow? 6 out of 30 is 0.2. If when we're doing probabilities, we're usually just going to write it as a decimal. You can leave it in a fraction, but make sure it's in the lowest terms. So if you're going to leave this as a fraction, leave it as 1/5. You could also say 20%. Any of those things are fine. So, does that mean that if I did this 30 different times, I pick up a piece of candy, put it back in, pick up a piece of candy, is it saying that 6 of those times I will draw a yellow? No, it's not based off what I saw happen, it's based off what we would expect because of what we know here. So the probability of a blue, so that gives us, alright, so what do you notice on the likelihood of it being yellow versus blue? Mm-hmm. Let's look at this example. Sophia has 3 tickets to a concert, but Yolanda, Michael, Kevin, and Marissa all want to go with her. To be fair, she randomly selects the 2 people that can go with her. Determine the sample space. What is a sample space? All the possible outcomes. So she is picking 2 people. So it's possible she could pick, I'm going to say, can I abbreviate? Yolanda and Michael. Or she could pick Yolanda and Kevin. Or Yolanda and Marissa. That is every option that includes Yolanda, right? So we're done with her. So what's the next thing she could pick? Michael and Kevin, or, okay, that's every combination involving Michael. What else could she pick? Okay, and any other outcomes? No, that's it. The sample space, everything that could happen. So what's the probability that Michael and Kevin get to go? Yeah, there's 6 different outcomes. Only one of those is Michael and Kevin. So 1/6. You can leave it like that. You can give me the decimal. Either way is fine. What would be the probability that Marissa gets to go? So we look, how many of these combinations involve Marissa? 3 of them. Out of how many total? 6. So 3 out of 6 would be 1/2 or 0.5. Okay, so if I ask you to interpret it, what does that mean when your probability is 0.5? %50 chance she would be selected. Or saying if we did 10 different trials, she would be selected in 5 of them. Okay. One more example here. A survey asked 500 families with 3 children to the gender of their children. It was found that 180 families had 2 boys and 1 girl. Estimate the probability of 2 boys and 1 girl using the empirical method. So empirical is what we actually saw happen. So how many times do we have 2 boys and 1 girl? Out of how many total? Okay. Now let's do the same thing with the classical method. So classical isn't looking at the 180 families that we found. It's looking at every possible combination and how many of them were 2 boys and 1 girl. Okay, there's different ways of doing that. We wrote out on the last one, we just kind of made a list, and we could certainly do that here. We could say boy, 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 girl, boy, girl, girl. You know, we could go through the list like that. Another option that we'll sometimes see is like a tree diagram. So we know we have 3 children. So for the first child, so if we start here, your options are either a boy or a girl, right? So there's child number 1. And then the second one. So if the first one was a boy, you could still have a boy or a girl for the second one. A girl, you could get a boy and a girl. So that's basically 2 children. And we needed 3, so we add 1 more set. So coming from this, we could have boy, girl from each of those options. So this is just another visual for your options. So you can see you could have boy, 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 girl, boy, girl, boy, or boy, girl, girl. Do you guys understand how to read that? So how many different outcomes do we have at the end? It's really just counting that final group. How many different branches do we have there? 8. So there's 8 possibilities. How many of them had 2 boys and 1 girl? So we could have taken like boy, boy, girl, or boy, girl, boy, girl, boy, boy. Are there any others? So 3. And 3 out of 8 is 0.1. 0.375. Is that the exact same we got before? No. So that is the difference on empirical versus classical. Empirical is what we see happen, classical is what we would expect to happen. And the more trials we have, the closer those 2 numbers will be to each other. If I took 5,000 families, I would probably have a much closer answer to the 0.375. The final type of probability is subjective. And that's one where it's just kind of based on personal judgment. So like the weather is an easy example of subjective probability. Now if you're looking at the chance of snow, you probably look at 3 or 4 different websites and see 3 or 4 different things because there is some personal opinion involved in that. It might be me looking at your homework assignments and say, well, based off your homework, I think there's about a 75% chance you'll get an A on the next test. Can I actually prove that? No. Could someone else look at it and disagree with me and neither one of us be proven right? Absolutely. So subjective is that personal judgment piece, something that we don't have the concrete data to go with. Any questions from you guys? So I am done. This is your assignment. However, I want you to pay attention to my note. A lot of these questions say find and interpret the probability. So the interpret is like that one where we said there is a 50% chance that Marissa gets chosen to go. I am not going to make you do the interpret piece because it's very repetitive to do that 10 different times, but make sure you know what it means. So on a test, I might ask you to do it once or twice, so make sure you can, but I won't make you write it on every question on your